Hello, good morning, good afternoon, good evening. Welcome to session explaining and detailing the open source OSCAL-Compass suite of projects. OSCAL stands for Open Security Control Assessment Language. We'll see details of what it is. And Compass for Compliance Automated Standard Solution, which is the aim of our project in the context of compliance as code for compliance automation. The members of the incipient team here are Vikas, Lu, Manjiri, Alejandro, Jen, Anka, and Yana Takumi. And we welcome new members. We are looking for, through this recording, to engage the community, to show where we are and what we need to go to. And we hope this team to grow and achieve the level of support for compliance as code for compliance automation that the industry needs. The agenda for today includes a brief introduction to compliance, what compliance is versus security, compliance artifacts, personas that are involved, and the life cycle of end-to-end compliance governance, details on the open security control assessment language that we are using for our compliance artifacts, the overview of the three projects under the Compass, OSCAL-Compass org, and the details on the community and the governance and how you will be able to contribute to move this project forward. We receive always the question when we start discussing about compliance, how does this relate to security? And this slide, I find it helpful to illustrate the relationship between compliance and security. So we are all aware, right? Security is first-class citizen needed in any type of environment. And it's a set of discretionary requirements to ensure the integrity and the availability and the confidentiality of the data involved in that particular environment. Compliance brings a level of mandatory requirements. So it's a minimum level of requirements that must be achieved in order to align with a particular certification, law, or standard. So the full spectrum from security best practices to, highest degree of compliance can be seen as an evolution of the requirement stringiness, right, from best practices to a highest level of requirements. The technology that we provide here supports the full spectrum, is regulation agnostic, and can be leveraged from the security discretionary requirements of a company, of an organization, and also, of course, for the regulated environments where we have specific compliance requirements. Next slide, please. So I'll hand the mic to Vikas. You are presenting, or you want me to present this one? I forgot in the...
This is the next one you are presenting.
Okay, perfect. Okay, so as we are talking about compliance, the question is, what are the artifacts that are typically involved in the compliance and compliance governance lifecycle? And we are all familiar with the documents that are available for the various regulations or for our own organization policies. And you have a list up there. And typically they are expressed as PDF or spreadsheets, and this is very difficult to leverage in a programmatic environment. So if we are looking at the content of these documents, the atom, right, the central element of those regulations are the controls. So we have here two examples. One is from NIST 853, the other one is from the NIST AI RMF of such controls. One is SC7, boundary protection, and the other one is the Management 2.2005, filter output for harmful or biased content misinformation. So one artifact that we are looking at, of course, is the catalog of these controls. Transformation of this catalog to suit a particular baseline, right, is a profile. A profile is a subset of these controls that are targeting a certain level of stringency. So you can have NIST 853 low, moderate, or high. So the difference with the catalog is that each one of those baselines is a subset, and they have parameters that reflect the level of stringency. Now, as we are moving from the regulation into the actual technology, we implement those controls, right, in various services or software or hardware or processes. So at the technology level, we express those controls in procedures or rules. And here is an example, two examples, one for the NIST SE7, the boundary protection, right? So if we are looking at cloud object storage or the Kubernetes or the VPC load balancing, the control SE7 is reflected in through those rules, that the cloud object storage is enabled in private endpoints, that the Kubernetes is enabled through the CIS service. And this translation of the control at the technology level is what we call the compliance governance. In the case of the NIST AI RMF control, we are looking at the bias score rule to be less than 20%, at the harmful content score to be less than 10%, and the model output, right, on the misinformation to be less than 10%. So this is a division of the control in specific rules at the technology capabilities level to be able, right, as you will see now in the next phase, to assess that particular control through those rules, right? So to assess the rules, we are using policy validation tools that provide checks. What they do, they collect the evidence, right, what we call the actual state from the environment, and they compare the actual state with the desired state expressed in the rule or in the procedure. And we have a pass-fail result. And that pass-fail, of course, it is aggregated across all the technologies that are implementing a particular control. And this way we get the posture of a particular control. So here we have the compliance part, as I mentioned, the governance, and then we have the assessment and the assessment of the risk, because the failures that we have at the check level can be associated with various levels of risk metrics. And this helps evaluate the overall risk of a particular environment. And then, of course, if we are looking particularly to putting a package together, right, the details about the controls together with their rules and the results associated with the rules provide a package for the authorization to operate. So now the question is, how do we generate those artifacts, and who are the personas involved to generate them, and what is the relationship between them. So no surprise, the regulations, the laws are the job of the regulation agencies, and they can be governmental, and those we have laws like HIPAA or FedRAMP, or they can be standards like PCI and NIST, or they can be best practices, as in the case of the CIS benchmarks or the SOC 2. Together with those regulations, the regulatory agencies provide also crosswalks between those regulations. So this is very helpful, because if I already implement a regulation, I'll be interested to know, well, how much of what I have can serve other regulations, and that's the basis of reusing existing posture and evidence for the new regulations that we need to maintain. So this is at the agencies level. Now, if we go at the organization level, we'll have a compliance team that and CISO and CXOs that are governing regulated environments and are taking decision what level of stringiness a particular environment or corporation or organization has to follow. So the compliance team will take those catalogs and will decide on the baselines, on the profiles with the level of stringiness that needs to be followed. Once this is done, then the technology that is involved in that particular environment, the hardware, the software, the services, the processes associated that now need to implement those controls. And as we will see in the coming slides, the OSCAL language allows, besides the support to express the catalog and the set of controls, allows also to express how those technologies implement the controls through their rules with associated parameters that the technology or the processes may expose, and also with support for providing resolutions in case of failure, with support to provide risk metrics in case of when the assessment platform is looking not only just pass fail, but create a score for the risk of that particular environment. And finally, we are looking at the control assessor policy validation tools that will provide checks in the case of automation, or will provide procedures to evaluate the controls that have been implemented by the technology in the regulated environment. And looking at the relationship between those personas, we'll see that they depend on the content that is provided by the others. And one of the most difficult part in compliance is that the people that are involved, right, going from A to D, have level of skills that are very different, right? So A is mostly high level, policy level, while D is very technical, typical developers that will develop that code. So our goal with one of the projects that you will see in the OSCAL-Compass, the Compliance Agile Authoring, is to provide a platform to allow those personas to collaborate in a way that allows each of them to work on their individual artifact using their individual skills, and creating an opportunity for a relationship between the various artifacts, and a way to translate everything in a common programmatic language that can be leveraged for the ultimate goal here, which is continuous compliance, so for compliance automation. So we'll think of this documentation of these compliance artifacts as a tool chain where these content, risk compliance content is generated, and of course the associated compliances code for the programmatic aspect of that. In parallel with the compliance content, we have the checks, the actual code that is expected at runtime to evaluate the posture of the controls. And they can cover various aspects of the stack, of the life cycle of the development, right, from day one to day two, of the specific technology, whether it is, Kubernetes or OpenShift. So those two, the compliance agile authoring with its Git repositories for the compliance information, and the checks, right, in their separate Git repositories for the code for the runtime, are both deployed in compliance administration centers for runtime in order to evaluate the system owner's environment posture. So the persona E here, the system owners, they will deploy their environment, subscribe to their services, deploy their applications, and they are going to associate profiles from the list of available profiles with their environment. And through the compliance to policy, we are going to administer now those requirements to the policy validation tools. So you see here, right, that we consume that information, we run the checks, we collect the evidence from the environment to be able to compare the actual state with the desired state. We generate results and inventory updates, and those are consumed in their turn, of course, by the system owners and also by the SREs, so that they understand what needs to be fixed in their environment to maintain compliance. These results, of course, are also consumed by the compliance officers and auditors. They are part of the packages that are put together on the GRC tools, together with the risk that can be calculated in this environment, together with the business risk and the financial risk in the GRC tools, can now help evaluate the risk of that business. So with that, I think we covered the main goal of what we are doing here, right? Compliance. The aim here is continuous compliance through compliance automation. And for compliance automation, we need support for compliance as code and standard. So next, we are going to talk about the standard.
Okay, thanks, Anka. So NIST has come up with a standard called OSCAL, which stands for Open Securities Control Assessment Language, and this is a collaborative work between NIST and FedRAMP. What OSCAL provides is basically a framework and a common machine-readable language for expressing these various compliance artifacts that we saw earlier, right? The content that is created by the regulators, the CISO team, the product owners, and so on, right? So NIST provides a framework and a language to represent these information in machine-readable format for use in compliance as code. Okay, so what it provides is basically it can help support multiple compliance and risk management frameworks such as the NIST 853 or the ISO 27001 and so on. It also provides the software and service provider to express and implement the controls that they support, the technology specific rules corresponding to those controls that would enable the assessment tools to validate whether the software or service is compliant or not. It also allows system owners to show how these controls are implemented in their actual environment in the form of a system security plan. And then the system security assessment plans basically can be used by auditors to define how the assessments have to be performed, or they can check whether the a implemented systems are implementing the controls properly or not. Further, it allows sharing of the assessment results or reports in a standard system assessment result format. And then based on whether the checks are passing or failing, a plan of action and remediation is generated to basically mitigate the risk associated with the controls that are failing. OSCAL also provides support for automated traceability from selection of security controls through implemented. So if we look at all the OSCAL models, the downstream models have a reference or link to the upstream model, so that from the last model, if we are looking at assessment result or so on, I can refer back to which catalog control this assessment result is for, right? So if you see the figure here, the top level model, the first model is the OSCAL catalog model, which defines, which is provided by the regulator in terms of what are the controls that need to be supported. The profile model is basically a selection of controls from one or more catalog, and it refers back to the set of catalog from which the controls are imported. The component definition and the SSP model would import the profile to say, okay, this is the profile that my software or service is going to implement, or this is the profile that my environment is implementing. And obviously the profile in turn refers to the catalog, so the full traceability is available. Similarly, the rest of the models like the assessment plan model, the assessment result model, and the plan of action and milestone model, they refer back to the preceding model to maintain that traceability. And this traceability basically helps capture, right, what are the control, the result for this, whether this result belong to which component, which control, and so on. This whole end-to-end information can be ascertained. Now let's look at some of the technologies that we have developed as part of the OSCAL-Compass set of projects to support compliance automation, both compliance as code and policy as code. So as we mentioned, right, OSCAL is both a NIST framework and a language for managing these compliance artifacts as code end to end, and it provides support for selection of controls through implementation and assessment to plan of actions and remediations and mitigation. Now, compliance TRISL is an opinionated implementation of this OSCAL standards. What it provides is basically it helps allow editing and manipulation of these OSCAL documents while making sure that these schemas are enforced. So one can edit these documents either directly in the JSON format, or we also provide editing in more human-friendly formats such as CSV files and Markdown files. And TRISL code would enable conversion from one format to the other, while also ensuring that these schemas, the OSCAL schemas, are adhered to. It provides both an SDK and a set of command line tools to allow its usage either through a programmatic means or through a pipeline. Another related project which builds on top of TRISL is the Agile Authoring Platform, which is basically a collaborative platform to enable various compliance personas that we saw in the previous slide to help create and manage their artifacts in their choice of interface, or such as the Markdown file or Excel file or CSV file. And it would and automatically this platform behind the scenes would use compliance TRISL to convert that source format into the OSCAL JSON format, right? So it is basically a GitOps based automated workflow that ensures that the artifacts are consistent both in the source format, which is a human readable format, and the OSCAL format, which is the machine readable format. So whenever one edits the source format, automatically behind the scenes Agile Authoring Platform would call TRISL to convert that back into the OSCAL format and maintain that consistency and traceability. Now, this was the compliance part. Once we have this set of controls and rules, we need to create a policy that needs to be deployed on the actual system to perform that check to verify whether those rules are passing or failing. And the compliance to policy project basically is helps bridge this gap from the compliance as code to policy as code, and it provides a GitOff-based extension to normalize the policy administration in various policy validation tools. What it does is it would take the platform agnostic compliance information and then translate it into the specific assessment tool related policy format that is required by those tools to perform the validation. Here we also provide a set of links to the OSCAL standard, the OSCAL-Compass GitHub organization, and the compliance Trestle project. Next, I'll hand over to Lou to talk about a little bit more details about Trestle.
Thanks, Vikas. I'll talk about, as Vikas said, I'll talk about Trestle. Trestle is an open source OSCAL SDK. It's an ensemble of tools that enables the creation, validation, and governance of documentation artifacts for compliance needs. So what Trestle envisions is that these artifacts are deployed in a Git repository as the single source of truth for managing these artifacts. And we rely upon, or we take advantage of Git and all the good things that it brings to manage change history, to control access and approvals. So we build on top of that and provide functionality that allows you to manipulate these documents. Trestle supports JSON format for representing the OSCAL data and uses Python as the programming language for easy scripting and enforcing of the schema. Trestle provides command line interface. It doesn't provide GUI. If you want to build a GUI on top of it, you're welcome to. So it uses a command line interface to expose its functionality for easy integration with CI/CD tools. And in addition to the JSON native format for OSCAL, Trestle also allows for a markdown format representation of the same JSON data for make it easier for humans. Humans like Markdown much better than they, generally speaking, much more than JSON. And these JSON files can be very, very large. And the Markdown can be broken down into manageable pieces for humans to manipulate. And we can, Trestle allows easy swapping between Markdown and JSON back and forth. So if we can jump to the next slide. So this is an attempt to depict the Trestle architecture. And in core Trestle, this is like the substrate on which the rest of the pieces are built. And it employs other open source tools like Pydantic and semantic versioning and other things that we don't want to invent ourselves. We just want to stick to the task at hand, and that is this support for OSCAL. In the core models, these are the actual representations in Python. And there's a semi-automated process that takes the models that NIST produces and transforms that into Python classes. And there are currently seven models: catalog, profile, component definition, system security plan, assessment results, and plan of action and milestones. And this code makes one Python class for each one of those. And each one of these classes enforce strict model specified constraints for example, for required fields, for valid values, and other kinds of things, so that when you actually try and either through the command line or programmatically try and create these models, these things will be enforced so that you're absolutely adhering to what NIST has in their schema. There's the adapter on top of that, the OSCAL adapter. And what the OSCAL adapter does is it allows you to, it allows for transformation from the JSON format into Python classes and back out again. Let's see, as far as the Trestle repository is created as using the Trestle init command. And it comprises a structured folder for containing the OSCAL artifacts, profiles, catalogs, and what have you. And then on top of or accessing that Trestle repository, you can do OSCAL editing and content authoring. And by OSCAL editing, what we mean is that there's commands and API for managing the artifacts that are in there. You can create, edit, split, merge, and validate. And for authoring, this is the part that does the transformations and allows for representation of Markdown as opposed to JSON representation. There's also a piece called Tasks and Transformers. And this is additional functionality that allows one to make transformations from other data formats into OSCAL formats. So for example, there's a task CSV to OSCAL CD that takes a CSV file and transforms it into an OSCAL component definition. Presently, there are 11 tasks defined, and one could envision other ones as needed. And lastly, there's a feature of Trestle that allows for plugins to allow for extension of the current Trestle functionality. And all of this is in support of applications such as CI/CD pipelines that, for example, Agile authoring would use. And so with that, I'll turn it back over to Vikas to talk about that part.
Thanks, Lou. So let's go a bit deep into the Agile authoring platform, which is a collaborative platform for helping various personas to author these compliance documents, artifacts in their preferred format, right? So as we mentioned earlier, Trestle supports representation of this information in Markdown format and has tools to convert that Markdown information, which is more human friendly, into OSCAL format. So basically what this Agile authoring platform provides is allows various personas to create or edit the content in more human friendly format, and behind the scenes it provides the pipeline and GitHub automation to convert this content whenever it is merged back into the GitHub repository, to convert this content automatically into the OSCAL JSON format. So it basically provides a set of workflows and pipelines so that whenever a user or a persona edit this content, it would automatically convert that back to the JSON format. And if there are any errors, it will bring those out if the content is not properly formatted and so on, right? It also triggers automatic updates to the downstream repos. If you see the set of repos here, for example, whenever a catalog gets updated, since there are profiles and other models that are dependent on the catalog, what will happen is this Agile authoring platforms connects all these dependent repos so that whenever an upstream artifact gets updated, we automatically create a pull request on the downstream repo to notify the persona of that downstream repo that a new version of the catalog or whatever is the upstream model is available, and they can go ahead and use that updated catalog or the model if they want and whenever they are ready to use it, right? So this whole automation is provided by this Agile authoring platform. Also, this collaborative, it provides support for collaborative editing so that whenever user makes some changes and merges back to the develop branch, there is a review process, and only after a reviewer approves the content, then only it would get merged, right? So without any review, the content would not get merged. So you need to have approvals, and we can configure whether you need one approval or more than one approvals are required to merge the content. Also, this Agile authoring platform provides automatic semantic release management. So whenever the owner of that repo feels that I have sufficient changes and I'm ready to make a new release of my catalog or a profile, they just need to merge their develop branch into the main branch, and automatically as part of that merge process, behind the scenes semantic release code would figure out depending upon what kind of changes have been made. So what we use is we use a format in the commit messages to figure out whether this is a fix, bug fix, or it's a feature update, or it's a breaking change. And based on those messages, the semantic release will figure out whether to create a major version or a minor version or a fixed version of the new release content, right? So all this automation and semantic release capability is provided by this agile authoring platform, and it links all the repos together so that whenever a content in one of the repo changes, it would automatically notify all the linked repos that this content has changed, and they can go ahead and update their content based on the updated information. Thanks. Now I'll transfer to Yana to talk about C2P.
Thanks, Vikas. I will introduce the overview of compliance to policy project. So far, we haven't mentioned how to integrate the compliance workflows with execution parts that actually collect and check the statuses from target system and services. There are a lot of security software to fetch the statuses from system and services, compare it with the desired status, and returns the security posture. The desired status is called policy, and we call the execution part policy validation point, or simply PVP. For example, PVP for Kubernetes resources such as pod are Kubernetes OPA gatekeeper. PVPs for cloud services and VMs are auditory and Ansible. Compliance to policy is to bridge compliance part and policy part to enable end-to-end integration of compliance workloads. C2P aims to provide flexibility in choice of policy engine and compliance framework to support various policy engines get involved in the compliance workflows. Combining C2P and terrestrial agile authoring, we can offer fully end-to-end continuous compliance automation. From the technical perspective, C2P functionalities is to generate policy from compliance as code, such as OSCAL, and aggregate the PVP native results as compliance assessment result in compliance as code as well. C2P has adapted pluggable design so that various policy engines can easily adapt to compliance as code. The plugin interface is kept simple, as it requires to write small pieces of code that implement two interfaces of the transformer from control list to policy list, and PVP native results to each control result. So other things are done by a C2P core. So currently we supported Kubernetes plugins for Kubernetes, OCM policy framework, and auditory. We would be very welcome for everyone to develop C2P by community driven, and also welcome to develop new features or enhance functionalities of C2P. This is an overview of compliance to policy project. Thank you. And I return the mic to Anka or Vikas.
Okay, Jen,
Thank
over
you.
to you.
Yeah, thank you, Yana. When I presented the personas that manage the artifacts of compliance, we have a set of personas that were presented, and I know that Jen works with those very teams and has experience with various types of such teams. And so before going into the community, I would like to give a chance, Jen, to mention to the audience that not only the personas that we have presented, but exemplify the type of teams that you have been working with the goal to invite all those types of roles as contributors to our open source. Jen, the mic is yours.
Sure. So the workflow that Anka talked about a bit earlier can work in many different contexts. In fact, the defined roles and their interaction with specific OSCAL documents would remain relatively static. But what can change there is the workflow itself and the different actors that can participate in these types of roles. Those other types of workflows can be accommodated, and the use cases can span from defining compliance capabilities for an open source project to defining your own internal organizational compliance requirements. So the benefits are beyond just regulatory compliance. And we will be exploring these use cases in more detail in future OSCAL-Compass community meetings. And in fact, on the next slide, I'll talk a little bit more about those community meetings and how you can get involved. All right, so now that we've talked about the projects and done an introduction, I want to talk about our governance structure and how you can get involved in the OSCAL-Compass community. So a great place to start is our community README. The community policies and documentation is still evolving. It's been recently defined. So the community README will have all of the updates that you need. We have a bi-weekly community call for OSCAL-Compass. They occur every other Tuesday at 11 a.m. Eastern Time. More information is available on the link, and these slides will be made public in our Google group and Slack channels, so you can take advantage of these links. I want to talk really quick about a high-level overview of our decision-making strategy. We always strive for a consensus-based approach, and we encourage discussion and collaboration where we welcome and encourage community feedback. In the event that consensus cannot be reached, or for very specific circumstances, they're documented in more detail in our governance documents, we will use an explicit voting mechanism to reach a decision. For our leadership, we have an oversight committee that oversees project health. This is across all the projects that have been talked about here. Usually consists of 3 to 7 members of project maintainers or project representatives. Currently, we have what's called our Bootstrap Oversight Committee. That's the initial identified oversight committee, and we will be defining succession and how oversight committee members are selected in future iterations of the governance document. And that is linked here on this slide if you want to learn more. We also have a set of contribution documents at the organization level to allow community members to understand the ways to contribute to OSCAL-Compass, but they are also available at each project level for more details defined by the project maintainers on how to interact with each individual project. Next slide. And here, keeping up with OSCAL-Compass and Trestle, there's a link to the OSCAL-Compass meeting notes with all the information about past OSCAL-Compass community meetings. We have recordings located there, our GitHub organization, and also a set of blogs that can provide you more detail and background about the projects. These blogs are also available on our organization profile. And as I said before, these sets of slides will be made available and public, so you can take advantage of all these links. All right, thanks.
Thank you, Jen. Thank you very much all for the presentation and for the outstanding contributions helping to move this forward. For the people in the audience listening to us, you are very welcome to join. We are looking forward to seeing you all in our community calls and, seeing among the collaborators, co-contributors of those projects. So with that, I will wrap up the call and we'll make sure we'll make available all the artifacts that have been presented here. Thank you.